provided to predict the behavior of the visitors on the website using the multinomial logistic regressions. So the data appeared to have 500 rows in observation, 6 columns variables, and at this event, my target it is to target is the variables, which is the user actions, and my cross validations, and I've done 60% for the trained data and 20% for the validation, and again 20% for the test data. So I've done a random weights just to have to experiment with the better decision that I can have. This it is the cross entropy models that I just got on the trained data, which gives me 92%. And
so a couple questions here.
Yeah.
So one, you need to be careful with your verbiage, because what's a cross entropy model?
No, just the function.
This is logistic regression.
Yeah, logistic. Yeah.
So, but you're saying train the cross entropy model, which would make me think that there's some other crazy model out there called a cross entropy model that I don't know about.
Yeah.
So also the underscore, so that kind of tells me that you literally just kind of like cut and pasted something out of your code and put that in your presentation, so don't do that. And why do we have 4 curves?
Yeah, this is things this morning I was trying to really to get it, but instead of giving me 3, it's giving me 4. And the same thing on the test. Just go back here.
Well, but okay, so computers are not smart.
Yeah.
And they just do what you tell them to do. So to say like it's not giving me 3, it's giving me 4, it means that you're telling it to do something that means it's like it's being told to give you 4 curves. And actually here you're saying like model performance on test set. So this actually seems to just be like the error curve on a single set. So the 3 would be if you were trying to plot all in one plot.
Yeah.
The model performance on the training set, the validation set, and the test set. But I actually would hope that I would not see a curve like this for those, because that would indicate that you're training your model against the training set, training your model against the validation set, and training your model against the test set, which is not what your validation and test sets are for. So I would hope that I would never, ever, ever see a graph with 3 curves that looks like this. And second of all, this actually appears to only be the test set that you have 4 curves.
Yeah, this is test set.
I think I'm gonna go ahead and guess at what you did. So I think Felipe had this problem that fixed it. So if you tried to just literally like plug and chug the code that I gave you guys.
Yeah.
For L2 regularization, like the cross entropy function with L2 regularization for when we were doing like binary logistic regression, then that would actually generate an error value that's like a 4x4 matrix instead of a single value. Because if you do
I just plugged it in.
Yeah, so you can't just plug in, you do have to think about what you're doing.
Yeah.
So if you do w.w, then if w is a vector, then that gives you the sum of the squared elements, right? Or the sum of your squared weights, which is what we're doing when we're doing L2 regularization. If w is a matrix, then w.w does matrix multiplication and you get a matrix.
Yeah.
But you're supposed to be using, so w.w gives you the squared L2 norm when we're doing L2 regularization with vectors, but when we have a weight matrix, we use the Frobenius norm. And so you can't literally just copy that code. It has to be something that would give you the Frobenius norm of the weight matrix W.
That also applies to multivariate, right?
Yes. So it could have been coded up as just the sum of W squared, which actually would have given you the L2 norm in the case that W is a vector, and would have given you the Frobenius norm in the event that W is a matrix. So that would have been maybe a more general way to code it up. But I want you guys to actually like look at the code and like think about what the code does, and like think about if it even makes sense for what you're trying to do, rather than just like assuming that it's going to work all the time in every situation and just like plugging and chugging with the code that are right for you guys. So that's why you have 4 different error curves, is because you literally just use the code that I wrote for you guys, w.w, and that's only that's only going to work if W is a vector. If W
Yeah.
is a matrix, that will not give you the Frobenius norm of W.
Yeah, but surprisingly, it does something on the train, which is up here, like 92, and then when it comes to the test, and then it drops down for whatever reason. So
that's fine.
it's telling me, yeah.
The thing is, I kind of don't even trust what you're doing here, because if you've made this plot against the test set, you're telling me that you've actually trained your model against your test set.
Yeah, to train, yeah.
You don't train your model against your test set.
No.
That would be silly to actually call one of your data sets a training set,
yes.
if you're going to train against the other sets too. It's called the training set because it's the only set you use for training.
Yes.
Right?
Yeah.
So where did this curve come from? Because this looks like a training curve.
No, the training curve looks different. Yeah, this is a training curve.
Because it looks awfully the same. And I also
okay, you don't want to see the
no, so I'm just wondering, like, what is it you did here to get a curve that looks like this if you didn't train against your test set? Because that's a curve that we really only see when we're training a model, right?
Yeah.
So if this is a thing that you got against your test set, then it appears that you've trained your model against your test set.
No.
Then where did this curve come from?
I've got these 3 data sets which is trained, then I feed the model into the train.
Yep.
And then after looking at the performance of the error that gives to me, and now taking the 20% of the remaining test, and then feed the model onto to see how it can perform on that one.
So fitting the model and training the model are the same thing. You don't fit the model to that data ever. That's the whole point of a test set, is that it's this data set that you've set aside and you've never fit your model to that data. You feed it into your model once your model is trained. So once your model has been trained to the training set, once it's been fit to the training set, you want to see how well is my model going to do against new data sets that I've not fitted to. And so you feed your test set into that trained model and just see what kind of error you get, but you don't fit it to the test set. So what you've done here is you fit your model to the training set, but you've also fit your model to the validation set, and you fit your model to the test set, which is not at all what you're supposed to do.
No, the validation test is actually the result that I've taken and then times it by the weight to get validation.
Okay.
Yeah.
Well, that sounds correct, but then where do we get these plots from?
This is actually, like just you said, I test this on the 20% of the data, the set.
Okay.
The set, yeah.
But then I would just expect like one error value, not.
Yeah, that is my question.
Not error values that would give you a plot. Well, you're the one that made the plot, so how is it that you don't know what the hell it is? Like,
this is my good question. Like, I was trying to say how this thing can give me like 3 things, but then this morning even trying to figure it out, it's just still not able to.
Yeah, so I would have to look at your code to be absolutely sure, but I'm already like 99% sure if you're generating plots like this that you're actually fitting your model to all 3 of your data sets.
Yeah, I'll pass that to you so you can check it.
Which is not what you're supposed to do.
Yeah. So if there is a correction to be made, which would be good for me.
Okay.
Yeah.
But do you understand conceptually, at least now that I say this, that you're supposed to train your model against the training set and never train your model to the validation or test sets?
No.
So don't do that ever. You train your model against the training set. You don't train it against the other sets.
That's right.
Once your model is trained, right? And once you've gotten a trained model by training it against the training set,
Mm.
you feed those other data sets in as input and then see what outputs you get and then see what kind of error that calculates to, and you compare those outputs to the targets.
Yeah.
Right?
Get it, yeah.
That's what your validation and test sets are for. You don't ever train your model to the validation or test set.
That's right.
Okay. Okay. Now I'm still confused because if that's right, then like.
No, I got what you say, but it's good that I sent you the code so they can
Yeah.
check.
And see, this is why we do presentations. this is exactly why. Okay. All right.
Yeah.
Cool. So yeah.
Yep.
Sounds like we need to. Geslan and I need to review the cross-validation process. Okay. So it is now 12:34. Roman just messaged. I guess he's not going to be kicked out for at least another week.
Что сейчас буду?